All right, let's get into the next section here. In this section, we're going to be talking about Dow plans and endpoint addressing. We're going to start by talking about Dow plan overview. What is a Dow plan within Call Manager? What are some of the Dow plan components? What are the different functions of a Dow plan? These Dow plan components, things like route patterns, calling numbers, essentially, things that allow us to process calls. So we have gateways, and we have gateway resources, and we have patterns, and patterns point to media resource groups, media resource group lists, and then media resource groups, and then we'll reference gateways from that perspective. How do we do our endpoint addressing within Unified Communications Manager? We'll also take a look at how Call Manager handles call routing. What is the process? What is the call routing logic that Call Manager is going to use? What are the different address methods and digit analysis methods that we can use? Depending on whether it's a skinny phone or a SIP phone, that will change. We'll also look at what the effect of variable length patterns are within Unified Communications Manager. What happens if we have overlapping patterns? How can we use urgent priority in that particular scenario to make sure that calls like 911 get processed quickly. And then we'll wrap up this whole discussion by going into discovery number 11, which is implementing endpoint addressing and call routing. And we'll wrap up with our summary challenge. All right, so when it comes to obviously a phone system, the Dow plan is a pretty critical piece, right? Dow plan is what I'm allowed to dial, the patterns I'm allowed to dial, the connectivity that we have to the PSTN, the way we route calls to the public switch telephone network or even over the WAN, the individual telephone numbers that exist or directory numbers that exist on the endpoints, and so on. So obviously this entire topic or this entire section is discussing how we manage these Dow plans, how we manage the endpoint addressing, and how Unified Communications Manager deals with these types of things or these types of configuration elements, from the context of, being a phone system, basically. So let's start our discussion by talking about what is the Dow plan in general, right? Dow plans include many different components. There are elements of classes of service, meaning that we have a way of restricting who can dial what numbers, based on their class of service that we define, and in the context of Call Manager, this is done through partitions and search spaces. We have endpoint addressing that's important as well. Endpoint addressing, as we defined in one of our previous lessons, is basically just the directory numbers that we have on our endpoints themselves. The extensions, the directory numbers, but there's other components to endpoint configuration as well. We could have speed dials, we could have bridge line appearances where we have an extension or a directory number that might exist on multiple phones. We can have different call treatment features like call hunting and call coverage configurations as well. So it's not just simply a matter of defining what the phone number is on the endpoint. It is also a matter of defining, essentially how those phone numbers can be utilized, and when somebody dials that phone number, what's going to happen with that particular call. So we have dial rules for internal as well as external numbers. Are we going to play a secondary dial tone? Would be an example of a dial rule that we might specify for PSTN dialing rules. Is this call going to get routed to a hunt pilot, and then we're going to send that to a hunt group, and then ring multiple phones if somebody dials this particular extension? Is the call going to be sent to an external resource? Like, for example, if I dial this extension, is it going to send me to an auto attendant that's configured as a call handler in Cisco Unity Connection, and so on? So how are we going to handle the calls, and how are the calls going to be processed as part of our Dow plan as well? In addition, we may want to also do digit manipulation. Prefixing digits, expanding numbers to an E.164 number, translating or transforming numbers completely. So Maybe somebody dials 555, but I want to convert that 555 to a PSTN number. So digit manipulation is one of those things that's part of our dial plan as well. For example, if I have a PSTN number and I tell my clients that if you want to, or my end users, if you want to dial the PSTN, you need to dial a 9 first as an access code. I don't want to send that 9 to the PSTN. I want to strip off that 9 and then send the regular number to the PSTN, because the PSTN is not going to know, or the provider is not going to know necessarily what to do with that 9. And they can't just assume that the 9 is an access code. So there are many cases in our dial plan where we have to do digit manipulation. We already talked briefly about class of service, but class of service provides me the ability to restrict what numbers people can dial, and we're going to use various functions for class of service. The two primary components for class of service in Call Manager, like I said, are partitions and search spaces. We'll get into that a little bit later on. Call coverage. If I ring an extension and somebody doesn't answer that phone, or that phone is not registered to the system, what happens with that particular call? Do we forward that call to voicemail? Do we send that call to another extension? Is somebody able to answer that call by using some sort of group pickup feature? Whether it's a sales group or a department that's responsible for answering calls, that kind of thing. What kind of enunciator messages do I play? One of the media resources within Call Manager is called the Enunciator. And that is the feature within Call Manager that plays feedback messages to the caller or the person calling. These Enunciator messages are kind of pre-canned messages or pre-recorded messages that will indicate if there's an issue with the call, what kind of issue exists, and how do we handle that particular issue, right? We also have call routing. Do I send the call to an ITSP SIP trunk? Do I send the call to a PRI? Do I route the call over the WAN? Do I route the call over the WAN with PSTN as the backup? For call routing, we have route patterns, and then those route patterns point to these route lists, and then route lists point to route groups. And then inside of those route groups, we have our gateway resources that allows us to identify how a call gets routed. And that's part of the path selection process as well. I have a primary way of routing a call, and then define secondary ways of routing the call, and so on. So if you can imagine, all these things, comprise our dial plan. It can get pretty complicated when you're establishing a dial plan for an enterprise environment, because there are a lot of different considerations that you have to take into account when you're trying to establish this dial plan. How are calls processed? How are they treated? How do I manipulate the digits? And it gets even more complicated when you start dealing with systems that are international, right? Where you have different types of numbering plans in different regions on the globe, and we have to be able to handle those different numbering plans and so on. All right, so dial plan design is a really, really important component to any phone system. You really have to understand how the dial plan is going to be implemented in your enterprise, and what are all the working pieces to comprise that dial plan. Not only for outbound dialing, but also for inbound dialing. Right? Do you have DID numbers, direct inward dial numbers, and how do we map those DID numbers to the internal extensions? Maybe internally I'm running through, I have configured 3-digit extensions or 4-digit extensions, and I somehow have to map those E.164 numbers, those 11-digit numbers, to those extensions. Is there a direct mapping? Is it just simply masking the last 4 numbers? Or are there actual full translations that have to take place to represent those numbers? Does that make sense? So that's a consideration that we have to take into account. So the dial plan can get rather complex, and if it's not implemented correctly, can cause lots of issues in your environment. You need to know what types of endpoints you have. The type of endpoint that you have will determine how it does dialing. For example, SIP endpoints can have local dial plans installed on the endpoint itself, or we can use the global dial plan that's part of Call Manager. SCCP endpoints rely on the dial plan that's installed in Call Manager to be able to facilitate the dialing from an SCCP endpoint. Also with gateways. Gateways are considered endpoints. Their endpoints are essentially endpoints that allow us to connect to the PSTN, but the dial plan for an H323 gateway is installed on the gateway itself, whereas the dial plan for an MGCP gateway is installed within Call Manager. So understanding the types of endpoints that you have is important as well, because it's going to affect how the dial plan is implemented on those endpoints. Do we have directory numbers? Do we have PSTN numbers? The directory numbers can be a bit of a challenge, right? Especially if you have a multi-site deployment. Think about it. In a lot of traditional telephony environments, the phone systems are not interconnected and they're not interrelated. You might have a PBX at branch 1 that is completely independent of a PBX at branch 2, the PBX at branch 3 and branch 4 and so on. And then when you move to a IP telephony environment, all of a sudden the branch phone systems are one. So if you happen to be using in branch 1 extensions 500 through 599, and then also in branch 3 you're using extensions 500 through 599, because normally those would be separate and not integrated. All of a sudden now when you implement your voice over IP solution, you have a scenario where you have overlapping dial plan. You have an overlapping dial plan, and you have to now figure out how you're going to handle that. Are you going to add an additional digit to make those sites unique? But then what happens if you have more than 10 sites? Then you might have to go from a 3-digit dial plan to a 5-digit dial plan, because you have 60 different sites you have to worry about. So you need a 2-digit site code to be able to manage, to be able to eliminate the possibility of having overlapping extensions, because you're implementing some sort of unique 2-digit site code for each site. So that's an important concept to consider as well. And of course, you also have to think of usability from the user's perspective. Users are generally happy if they're dialing a 3-digit extension or a 4-digit extension, or if they have to remember a 3 or 4-digit extension. But think about it. If I have 15 sites in my corporation, and normally those 15 sites would be separate, for running separate, a separate PBX, that's kind of, one of those gray boxes on the wall, a proprietary PBX that just has local PSTN access, and it doesn't have any IP connectivity or IP intelligence. We don't have to worry about making sure that the dial plans are unique, because the PSTN access is going to ensure that, because we have different area codes and different prefixes that are used in different geographic areas around the globe. But now if I incorporate this whole system as an IP telephony system, and I've got these 15 sites, now all of a sudden the 3-digit extension design, or the 3-digit extension configuration, is not going to work for me, because now I have to ensure that each site has kind of a unique set of extensions, so that if I am doing WAN-based calling, site-to-site dialing, that I can dial extension 555 and know that that's going to ring Bob's phone at branch number 3, right? So now you say, okay, well, we have 15 sites. Let's go ahead and implement a 5-digit dial plan, and let's assign each site a 2-digit access code. And then all of a sudden you acquire another company, and you go from 15 sites to 500 sites. Now all of a sudden a 5-digit dial plan isn't going to work anymore. You now need to move to a 6-digit dial plan, where you have a 3-digit access code, because now you have over 500 sites, which means you have to have at least 3 digits to identify the site, and then you have to have your extension dialing within the site itself. And these are just examples, by the way. Some people decide they don't want to do a 6-digit dial plan, so they'll come up with some other way of identifying or making sure that the dial plan is unique for each of those locations. We're going to talk, I've mentioned this term a couple of times, E.164 structure. E.164 is something we'll talk about in more detail a little bit later on, but basically it's a way to define the formatting of numbers internationally. It's an ITUT recommendation, and it basically defines the general format for international telephone numbers. All right, so any kind of Dow plan that conforms to numbers in this particular E.164 format, they're going to be limited to 15 digits, excluding the international calling prefix. So we're talking about the number internally, and then we simply represent the numbers based on that. So we have geographic areas that we can identify, and then we have global services and networks and so on. So E.164 is just kind of a way for us to create this global standard for identifying how numbers should be structured around the globe. Despite having that, though, there still is a disparity, a huge disparity between how countries implement their Dow plans. In the United States, we use the NANP, the North American Numbering Plan. That's a 10-digit dialing structure, right? So we have our country code, which is 1, and then we have our area code, which is a 3-digit value. Then we have a prefix, which is a 3-digit value. And then we have the subscriber identification number, which is the last 4 digits of the phone number. But the E.164 format really only kind of defines a couple of pieces. It defines the country code, which is some sort of 3-digit value, at least, well, up to 3 digits, I should say. It could be anywhere from 1 to 3 digits. And then we have the subscriber number, which can be a maximum of 12 digits. All right, so a lot of different countries will do different things with that subscriber piece, which means that we have to deal with non-standard number formats globally. Some countries might be using a 7-digit number, subscriber number. Some countries, like in the United States, we use a 10-digit subscriber number, and so on. All right. But the numbering formats are, I wouldn't say regulated, but they're definitely defined. All right. So you have a national destination code, and then you have kind of your national subscriber code. That's part of that E.164 process. We'll get into that a little bit more when we start to talk about globalization and how Call Manager handles globalization, and so on. We have dialing domains. Dialing domains essentially allows us to identify, sites and regions. I kind of alluded to that when I was talking about the different branch locations. Now you could expand this to the globalization concept, where we're also talking about dialing domains throughout the globe. But dialing domains allow us to establish the set of rules that we're going to use to dial to different regions, right? We also have the potential, at least, for overlapping patterns. We've been doing this ever since the phone was invented, trying to come up with a way of ensuring that no two individuals would have the same pattern. Because phone systems traditionally in the past were very analog. We were doing some, actually literally human-based switching with the folks that were in the switching call centers, but then that switched over to some sort of relay-based system. But it was basically static logic that was configured in the phone system that said, if you see this area code, we're going to route the call to this general PBX or this private branch exchange. And then if you see this prefix, it's going to go to this secondary exchange. And then if you see these last 4 digits, it's going to go to this particular subscriber. But what happens if we have overlapping patterns? One of two things will happen. Either we won't be able to process the call because we can't identify where that call is supposed to go to, or we're going to have what we call post-dial delay. All right. Post-dial delay is an issue where the system doesn't know what you're dialing, so you have to wait for the T302 timer. It's called a T.302 timer to expire before the call gets processed, because call manager might be waiting for additional digits. We'll talk about that a little bit later on as well. Of course, a huge aspect of any phone system is emergency dialing. Life services and human services are very, very critical. People want to be able to pick up the phone and dial an emergency number in case there's an emergency, and they want to be able to know that they're going to get to those emergency services, whether it's 911 or 311 or whatever it might be, depending on the region that you're in. You want to be able to pick up the phone and reach those emergency services. And you want to make sure that the process for dialing those emergency services is uniform, right? You don't want to go into an office and you dial 911 and 911 doesn't work. And then all of a sudden the company is liable because they didn't provide adequate resources to 911. But there's another aspect to this, right? With emergency services and emergency dialing. It's being able to identify where the subscriber is. When we move to IP telephony, the phone becomes a computer endpoint. It has a logical presence in the network. It doesn't have a physical presence in the network. When we were using traditional telephony configurations, the phones were physically tied by a wire to a port and a line card on the PBX. So you actually literally had a cable that ran from the phone to the PBX, and it was terminated on a particular port on that PBX. So it was very easy to identify where the physical location of that phone was. With voice over IP, the phone is logically connected to the network with the TCP/IP stack, so there's really no way, I wouldn't say there's no way, there's obviously lots of ways with E911 and other features, but it's not like a traditional phone. We have to come up with other ways of being able to identify where that phone exists, and that's where E911 comes in, and being able to do electronic 911 services with emergency service providers and so on to be able to identify the location of a phone. That's a pretty important concept. Not only for outbound emergency dialing, but also to be able to identify the location. I mean, think about it. You could have a branch office in New York, and the person picks up the phone and dials 911. That call gets routed over the WAN and sent out the headquarters location in Miami, and all of a sudden you're connected to the 911 operator in Miami, but you're in New York. That's a highly likely possibility. If it's not designed correctly, that would definitely happen. And obviously that would be kind of not very useful for the person that needs those emergency services. All right. So 911 is something that we have to consider. And then also we have something called tail end hop-off, or THO. Tail end hop-off is a way for us to do things like toll bypass. This is not as much of a consideration in most modern systems today because long distance doesn't really cost anything, or at least little to nothing like it used to in the past, right? In the past, you used to have to pay for long distance because the circuit paths and the long distance providers and the long distance carriers actually had to have physical equipment and physical circuit paths to support the calls that went across the country. Now everything is IP telephony, so it's really just a matter of bandwidth. So there's a much better economy of scale with regard to being able to handle those calls. So long distance costs little or nothing these days. But in the past, we would consider, okay, let's say I have a company and they have offices in New York and LA. But I'm trying to do kind of follow the sun service or follow the sun customer service or sales. I might say, you know what, in the mornings, I want my New York people, because they're going to be up before the LA people, I want my New York people to handle the sales. But in the evenings, I want my LA people to handle the sales. But what if these salespeople are calling people in New York? So what I would do is I would set up the call to route over the WAN, and then I would drop the call off in New York at the New York office to the PSTN, because that would be considered a local call as opposed to a long distance call. And that's what we call toll bypass or tail end hop off. It's, again, kind of a synonymous term really, but it defines the ability for us to be able to use our own infrastructure as our transport mechanism, because this is data traffic really, not traditional PSTN voice traffic, and I can manipulate the calling, the call processing, and I can manipulate how the calls are going to be select their paths and so on to avoid those toll charges. All right. As you can see, just from the initial discussion here, it's really, really critical that you understand how the Dow plan works. And one of the major tasks as an implementer and as an engineer in designing these systems is to sit down with the customer and identify with the customer exactly how they want their Dow plan to be established, especially if they're coming from a traditional PSTN/PBX environment and they're moving to a voice over IP environment. You're most likely going to have to make some significant changes in how the calls are handled, how the Dow plan is established, and so on. Of course, you want to be able to document that as well. You need to make sure that you document, how are my endpoints going to be addressed? Am I going to have just a primary extension on those endpoints? Am I going to have a primary extension and a rollover extension? How many calls would I allow on a particular extension? In Call Manager, in a traditional phone, like a traditional PBX phone, you had a physical line, and you were pretty much limited on how many calls that phone could support at one time. With an IP telephony-based phone, it's really based on the bandwidth that phone supports. And if we have gigabit interfaces, you're talking about having the ability to support hundreds of simultaneous calls to that endpoint without starving out that bandwidth. So it's no longer, you get, one line or a 2-line phone or a 5-line phone. You could potentially have hundreds of calls going to an individual phone. So how are you going to handle that? There is a configuration in Call Manager that allows you to limit the number of calls that a phone will receive. There's a maximum call limit, and then there's also a busy trigger limit. And I believe the defaults are still 2 and 4. The busy trigger is 2 calls, and the maximum number of calls by default supported on an IP telephony endpoint is 4. But I don't believe that that's changed. All right, and you want to make sure the Dow plan documentation is up to date. Who's responsible for implementing that Dow plan? Who's responsible for testing that Dow plan? And then, of course, you need to document it. Dow plan documentation is really, really important. I can't tell you how many times I've done an implementation where I sat down with the client and I said, okay, we're going to be migrating you to Call Manager from this Nortel PBX. Tell me everything about your Dow plan. And then we do the migration, and then all of a sudden, this fax machine isn't working, or this toll-free number that's supposed to be routed to this DID isn't working, or these DID blocks are not working, or the number plan all of a sudden is overlapping because we've integrated all these offices together into a single phone system. So it's really, really important, all right? That's why we spend so much time talking about the Dow plan in this particular class, all right? What is the main characteristic of Dow plan documentation? Documentation can be generic and non-specific. No, you'd want the opposite of that, obviously. Documentation does not require descriptions of responsibilities and processes. The big box at the top there that says clear responsibilities and processes would probably negate that one. Documentation is only needed for complex Dow plans. It's actually not true, because one of the biggest concerns that you have, with Dow plans is toll fraud. We've run into a couple of scenarios where clients have contacted us and said, we just got a $10,000 phone bill because somebody was able to manipulate our phone system and make long distance or international calls and they were, doing that every day for hours and hours and so on. And we have to go in and try and figure out what the holes are in the Dow plan that allowed that to happen. So that is a consideration that you have to take into account. And so to say that you only need this for complex Dow plans is not true. Every Dow plan has at least some complexity to it. Every single Dow plan. Now, a customer might come to you and say, you know what? We don't really care. I just want everybody to be able to dial any number. And we've had customers that say that. They, it's a small office. They have 50 users or something like that, and everybody's kind of accountable and responsible, and they don't want to really deal with, Susie can dial international and Bob can dial local numbers and the lobby phone can only dial internal extensions and so on. Let's just make sure that every phone has the same configuration. So you might just say, okay, well, I'll just create one partition and one search space, and we'll just put all the numbers in the partition and just give everybody that search space. And then 6 months down the road, the IT manager says, you know what? My CEO now wants us to implement a structured dial plan where only certain phones have the ability to dial certain numbers. Now all of a sudden you have to go back and redesign the entire dial plan because you didn't put that structure in place in the first go around where you could actually just simply manipulate the restrictions. So even if a client comes to you and says, well, we have a basic dial plan, it's very simple, you still want to build that structure in place. You still want to have partitions for internal calling. You want to have partitions to store local patterns. You want to have partitions to store emergency patterns, long distance patterns, and so on, so that you have that structure in place so that when the customer comes back to you and says, oh, we want to change this now, you don't have to redesign the system. So even in the most simplest designs, even in the most simplest scenarios where you have a very simple dial plan, we still try to put that structure in place that makes it easy for us to manipulate that dial plan down the road when inevitably they decide that they want to change that because somebody abused the system or some auditor came in and said, nope, you guys are susceptible to this type of attack or this type of fraud because you didn't do these types of implementations. Does that make sense? So, I'm kind of harping on it a little bit, but you get the idea. The dial plan and dial plan design is really, really critical. It's a phone system, right? It's a phone system. So it's supposed to be able to handle dialing. So the answer to this particular question is the documentation has to be up to date. And it might change. I don't know that it's as dynamic as, say, like a security policy or business continuity plan or something like that. But dial plans do tend to change as you add more users. We have scenarios like this whole 2020 scenario where everybody's working from home, right? Now all of a sudden, what do you do with all the phone calls, right? How do you handle that? Are we going to go ahead and now move everybody to a Jabber type of phone and then have, or just to make everybody use their cell phone? What do we do with all the calls that are going to the office? What about the auto attendants that we have, right? And how are the auto attendants supposed to handle the call? Maybe we don't have anybody in the office to handle the calls anymore, so we have to establish an auto attendant. So, those are considerations that you have to take into account too. That's the dynamic nature of the dial plan, I guess we could say. All right? Sorry about that. All right, so what are the components of the dial plan? As you can see from this diagram here, it's pretty straightforward, right? We have our endpoint addressing. The dial plan as a whole is our numbering system, right? We have our blocks of telephone numbers, which are usually going to be E.164 numbers. Those go to our phones and allow us to dial in and out of the system. In North America, we use the North American numbering plan, as I said. We have a 3-digit area code, and then we have our 7-digit telephone numbers. But even the 7-digit telephone number is broken down into a couple of different pieces, right? We have a kind of a 3-digit kind of sub-area code, if you will, what we call prefix, and then we have the 4-digit subscriber code. But the dial plans contain all the dial patterns that we're allowed to dial within the particular system. And it could be access codes to get from site to site. It could be an access code that would allow us to dial to the PSTN. I mean, there's all kinds of reasons why we might have access codes. We could even have specialized codes that we've defined within the system. Service numbers like 611 and 411 and 311 and 911 are what we would consider to be specialized numbers that allow us to access special services that the phone company is providing, and so on. The E.164 addressing, of course, is our number globalization. But within the dial plan itself, we have our endpoint addressing, and by the way, that endpoint addressing doesn't necessarily just have to be a phone. It could be a hunt pilot to ring to a group of phones in a sales department. It could be a voicemail pilot that would send a call to voicemail. It could be a 3-digit number or 4-digit number that allows you to access an overhead paging system. It's any kind of internal number that allows us to access a internal resource. It could be an elevator phone, with PLAR configured on it. It could be, I'm just thinking of some of the examples of how we've used numbers in the past. It could be a number that you dial to open up an exterior gate, so people can access the parking structure and so on. All right. The next component of the dial plan is the call routing and path selection component. If somebody dials the number, how do we handle that call? Does that call go to a hunt pilot? Does that call get routed to a SIP trunk? Does the call get routed to a PRI? And even we can get into as much detail as saying, is it going to use the top or the first channel in the PRI? Is it going to use the fourth channel in the last channel in the PRI? That kind of thing. So that's how we handle the call routing and path selection. The idea is that when you dial the number, the system understands, based on the logic that you've programmed into that system, how to process that call. And we can even incorporate AAR functions within that, or automated alternate routing. So if a primary path fails, if the primary call routing path fails, do we route it over a secondary path? And can we do that transparently so that the end user is completely unaware? Which may require, by the way, that we do some sort of manipulation on the number to be able to facilitate that rerouting function. Does that make sense? So obviously, if I'm doing WAN dialing, that WAN dialing doesn't have the same requirements as if I was doing some traditional PSTN dialing, where I would have to have, that standard structure, or calling structure that you would have to have with, routing calls over the PSTN. Digit manipulation is important as well. How am I going to process the calls? For example, we talked about this in one of our previous lessons, being able to do number identification. ANI, automatic number identification, is the caller ID. And DNIS, dynamic or dialed number identification service, is the number that we're dialing. So I might be dialing from my extension, and my extension is a 4-digit extension, but I don't want a 4-digit extension to show up as the ANI information when I'm sending the call to the PSTN. So I would do some sort of post-dial manipulation that says, go ahead and take that 4-digit extension and expand it to the E.164 format, so whoever's receiving the call will know that this person is calling. Or maybe it's a DID. Maybe I have an E.164 number that I have published on my business card, my 10-digit phone number, but I want that to ring to my phone at the office, but my phone extension at the office is extension 101. My DID number is 707-555-1212. I need to be able to translate that 707-555-1212 number to that extension 101, so I'm going to have to do some sort of inbound routing, inbound translation or transformation so that the call gets routed to the extension. So that's part of any phone system, is to do some sort of digit manipulation. At a minimum, we're going to do some sort of digit manipulation when we're trying to do PSTN dialing, because almost always we'll have some sort of access code that we use to be able to identify that we're dialing to the PSTN. The reason why we have the access code is that in the North American numbering plan, any numbers that start with 2 through 9 can be PSTN numbers. We don't ever start a PSTN number with a 9 or a 1, but any number, we could start with a 9, not a 1. But any number that starts with 2 through 9, well, that's basically the whole range of numbers that are available. So if I didn't have an access code to allow me to identify that I'm actually trying to dial the PSTN, basically every one of my phone numbers would overlap at that point, because I would have to be able to identify the difference between a PSTN extension or a PSTN pattern and maybe an internal pattern that I might be dialing internally. So digit manipulation is a big part of setting up the dial plan as well. Calling privileges, as we've already mentioned a few times, every phone system is going to have some defined class of restriction or class of service that we're going to define. We don't generally want all of our users to be able to just dial whatever number they want, so we have to be able to identify what numbers are restricted, who can dial what, and we do that with partitions and search spaces within Call Manager. On an ISR router, if we're running like Call Manager Express or CME, or we're running an SRST type of box, we would set up our dial plan with what we call cores, or class of restrictions. It's a similar concept, basically, to partitions and search spaces, very, very similar to partitions and search spaces. And we can identify the dialing restriction in that case. And by the way, the Call Manager system provides us the ability to establish dialing rules and dialing restriction rules that are time-based as well. So it's not just a matter of establishing who can dial what numbers, but it could even be during the time of day. I mean, if you think about it, you might have a scenario, I've never run into this personally, but I could see how it could be an issue, where you might have a cleaning crew that comes in at night, and they know that the CEO's phone has the ability to dial international numbers. So they just sit at the CEO's desk and they make calls, right? And they do whatever they need to do. Or somebody might work at the office, and they know that their office phone has the ability to dial international calls, so they forward their phone to an international number, and then when they call their office phone, which is a local call to them, the call gets forwarded to the international number, and they're able to now call basically internationally for free. There's all kinds of considerations when it comes to toll fraud and toll fraud prevention that you have to consider. We actually have a whole separate section where we're going to talk about toll fraud in detail. All right, call coverage, really just a kind of a generic term that allows us to describe how we're going to handle calls if the call is not answered, if the phone is busy. Are we doing any kind of special features like call hunting or group pickup? The idea is that we basically want all of our calls to be answered, and in order for that to happen, we have to have a way for those calls to be answered. Even if it's just as simple as send the call to voicemail, that is still considered a call coverage option, right? Just simply sending the call to voicemail. So that's part of your dial plan consideration as well. We also talk about call coverage from the perspective of failed, if there's a failure. If the branch, for example, loses connectivity to the headquarters location and the phones are now kind of stuck on this little island, how do we handle the calls on those phones? Do those phones even have the ability to register? And that's where we get into the use of SRST, or what we call survivable remote site telephony, or SRSV, Survivable Remote Site Voicemail, to be able to provide the same basic functions for calling that we would have if the phone system was fully operational. All definitely considerations to take into account. All right, so these are kind of the components, if you will, of the dial plan. All right, now what about endpoint addressing? When I'm thinking about endpoint addressing, we look at this diagram here, it kind of describes exactly what we need to consider when it comes to identifying our endpoints. They're using a 4-digit dial pattern here, or dial plan here. We have 3 different sites, so technically we wouldn't have to use a 4-digit dial plan, but a lot of people have kind of standardized on either a 3-digit or a 4-digit dial plan in most enterprises. But we don't have any issues in this particular case because we don't have any overlapping extensions, right? The headquarters location is the 2000 extensions, site 2 is the 4000 extensions, site 1 is the 3000 extensions, and we don't even have to worry about dialing any kind of site codes or creating some sort of distinguisher that identifies the different sites uniquely because we don't have an overlapping extension plan. But does that scale well, right? This works great if you have less than 10 sites. And actually it would have to be less than even that because you would have to have some sort of PSTN access code. So 9 or 8 or whatever would be out, which means, and you wouldn't have really any extensions that start with 0. So you really would have only a couple of, well, actually that would be 8 different sites that you could support with this dial plan by itself. Now, you get more than 8 sites, all of a sudden now you're going to have overlapping extensions. You guys follow what I'm saying, right? So that's a consideration. Now, in this particular example, every endpoint has an extension that basically represents its actual location. And ideally, that's what we would love to have. We don't want to have, we want to be able to identify the physical location of the phone based on its assigned directory number. Now, it's not a big deal. If we have fewer than 100 people per site, we have fewer than 100 people per site, and we have 20 or 30 sites, we can still get away with a 5-digit dial plan, right? Because we would have to have at least 3 digits to represent the extension, and then 2 digits to represent the actual site code itself. So we're talking about only really expanding the numbering plan by 1 digit. And people will get used to it. You'll say, oh yeah, if you want to call HQ, you have to dial a 5 and then dial the person's extension. If you want to call branch 1, you have to dial a 4 and then dial the person's extension. And in that particular case, then the individuals can have kind of overlapping extensions because you're able to identify the sites individually based on the site code that you've created. So people will eventually get used to it, and they'll get used to the dialing plan. But it gets rather complicated when you start to get into a 6-digit dial plan or even possibly a 7-digit dial plan, which is entirely possible, by the way. I've seen large enterprises where a 7-digit dial plan was required because they have so many sites and so many users per site. So you're basically talking about just doing regular 7-digit dialing that you would do like on a regular PSTN. All right. So obviously, if I'm dialing over the WAN, I could dial the extensions directly. So instead of dialing 512-555-3001, I simply dial 3001. If I want to dial site 2, dial 4001. In this particular case, though, I don't have any WAN connectivity to site 2. I only have PSTN connectivity to site 2. So I don't necessarily want to go back and tell my users, well, you have to dial the full E164 number. We don't have any WAN connectivity. You're going to tell them, go ahead and dial the extension, but you're going to do the post-dial digit manipulation that expands that number to the E164 version and then sends the call over the PSTN transparently to whatever the user's dialing in this particular case. All right. Also, we would want to consider our call path selection based on the fact that we do have PSTN paths and we have WAN paths. Are we going to use the PSTN primarily? Is it cheaper for us to use the PSTN and reserve our bandwidth for data, or is it cheaper for us to use the WAN for voice and use the PSTN as a backup? In the past, that question was answered fairly easily because it was always cheaper to go ahead and route the call over the WAN. Data bandwidth was always cheaper than voice bandwidth, or at least voice circuit paths. Nowadays, it's kind of the opposite. Data tends to cost more than voice. Well, data becomes voice, basically, so they're kind of together anyway. But we also want to have the ability to be able to do both, right? The WAN connection might have the priority, but if the WAN for some reason is oversubscribed or not available, I want to be able to send the call over the PSTN. All right. Here's another example. In this case, we're doing digit manipulation. A user on phone 2003 dials 4001 to reach a user at site 2. HQ and site 2 are only connected with a PSTN connection, so that 4001 obviously is not going to work over the PSTN. That dialed number needs to be transformed to the 408-555-4001 number. So we have to, obviously do that in our dial plan or digit manipulation after the 4001 was dialed. Example number 2, we see a call is sent from the PSTN to 512-555-3001. And then we want that number to be trimmed to the extension length of 4 digits so that, we have some analog gateway or some gateway that's connecting that particular endpoint. And we're probably addressing that endpoint based on its 4-digit number, not based on the 7-digit number. So we want to translate that down to its 4-digit number. I mean, I'm kind of repeating myself a bit here, but I think you guys get the general idea of what we're talking about. Having the ability to be able to manipulate the digits, manipulate the numbers to meet our specific requirements. All right, that's part of our dial plan design. All right, calling privileges, another component to consider. Do I have the appropriate privileges to be able to make a call? Calls can be permitted or denied based on who's placing the call and based on what number they're dialing. All right. And I did mention this previously. This is done through the use of partitions and search spaces. Specifically, the partition is the phone book that the number gets listed in, and the search space is the list of phone books that you have access to when you want to place a call. So it's really actually the search space that defines the class of restriction itself. The partition is kind of just the phone book that the number is listed in, and the search space gets assigned to the device, or the search space gets assigned to the line, and that's what's going to define what that person can dial. And we'll get more into detail on how search spaces are parsed and how Call Manager looks at search spaces. If I have a phone search space in combination with a line search space, how do I decide how the call is going to be processed or what the class of restriction is for that particular call? We'll get into that later on. They say phone 2001 wants to dial the PSTN or place a call to site 2. It has a search space that includes the 4000 extensions in its list of phone books, but 2002 does not. So 2002 would get a fast busy, indicating that the call cannot proceed. All right. Another feature is call coverage. Like I said, call coverage provides us the ability to identify how a call is handled, either through some sort of automated call handling process like a hunt pilot. Call hunting provides us the ability to create a pilot number, and then when somebody dials that pilot number, that call gets answered, and then we have instructions on how the call should proceed. Is it supposed to ring a group of extensions? Does it ring them in a round-robin fashion? Does it broadcast the call to all phones? Does it ring the phone that was next in line, basically in a circular fashion type of thing? That's what call hunting allows us to do. If I call somebody and they're on the phone and their busy trigger has been reached, so typically the busy trigger on a phone is 2 calls, so the person's on 2 active calls, one's on hold and one's active or whatever, but they have 2 calls going to their phone. What do I do with that call? Do I send it to voicemail? Do I forward it to another extension? And so on. We also have the ability, of course, to forward our phones using call forward all, to forward all calls that go to a phone. That's a form of call coverage as well. Somebody might be out of the office, but they don't want to miss an important call, so they're going to forward the phone to their cell phone, and then when the calls come in, the call gets rerouted to the cell phone. That would, of course, require their appropriate class of service as well. But that's when we talk about call coverage, that's what we define. Now, the takeaway from all of this, because I think most of this probably makes sense as we talk about it, the takeaway from all of this is these are the kinds of things that you have to communicate with your customer when you're designing a phone system. And you almost do it to this level. You say, okay, let's go ahead and talk about the normal call handling rules. How am I going to handle calls normally? What are some of the general configurations of the phones? What is their busy trigger? How many extensions are they going to have, and so on. And then what are all the special use case scenarios now that I have to consider for call handling in the system? You guys have a sales department and you have 5 people in the sales department and you always want them to be able to answer the call. So let's go ahead and set up a hunt group for those 5 people in the sales department, and then we'll create a pilot and send the call there. You have some paging requirements, overhead paging requirements. And you got 5 different buildings. So let's go ahead and set up 5 different paging extensions and connect those to the paging system, so that when somebody dials a particular extension, they know that they're doing a broadcast page to that particular destination or whatever. It's amazing when you're doing these implementations how many of these kind of unique scenarios tend to pop up. I mean, if you just think about what you're doing in your own enterprise right now, you may be able to think of at least a few different unique scenarios that you would have to consider when you're doing the design. So it's definitely something that you have to take into account, something you have to consider. All right. So which 2 options are considered a Dow Plan component? Endpoint addressing definitely would be one of those components. Fax server is just really, obviously a piece to a phone system, but it's not really a Dow Plan element. Call coverage would definitely be a Dow Plan element. And again, a third-party PBX integration or voicemail system would be just, again, another example of a component of a phone system, but not necessarily part of the Dow Plan. So the next thing we're going to talk about is endpoint addressing. We think of, kind of the most basic form of endpoint addressing is just an extension that gets assigned to an endpoint. But there's more to it than that, right? Because if we're using SIP, for example, we could actually use a SIP URI, or what we call a directory URI, to actually address that particular endpoint. So it doesn't have to be a traditional 4-digit extension or 3-digit extension that allows us to identify that endpoint. Now, usually it is going to be some sort of directory number that gets assigned to the endpoint, but it really just depends on how we're deploying the endpoints in our environment. By calling that directory number or by sending the call to that directory URI, obviously the call is then going to get routed to that endpoint, and then that person can answer that call and proceed with processing the call. So endpoint addressing is a way for us to actually identify how calls get routed to the individual endpoints themselves. All right. So we see here 1001 is on the phone on the left, 1002 is on the phone in the middle, 1099 is on the video endpoint on the right. And we define that, of course, in Call Manager. When we provision our endpoints, we assign extensions to those endpoints. If we're doing endpoint addressing by number, there is a consideration as well. We might have an internal directory number that maps over to a particular endpoint, and that's what people inside the organization would use to reach that particular destination. But we also might have what we call DIDs, or direct inward dial numbers. So we have a PSTN DID number that allows us to reach that endpoint as well. Now, oftentimes what companies will do is they will try to establish their internal extension dialing plan based on the block of DIDs that they have. So you have this E.164 number with the plus, or the North American number. They're basically the same thing. The only difference is the one has the country code and the other one doesn't have the country code. But we have that number that kind of maps to the extension. So 408-555-1001, we simply take the last 4 digits of the DID number, and then we strip off the leading digits, and that becomes the extension. So that's kind of a nice scenario. It's easy to manage. It's very well organized, but oftentimes it's also difficult to achieve, especially if you're moving from an already established phone system to an IP telephony phone system where all of the users within the environment are kind of integrated together, because it ends up being that the extensions that you want, or the DID blocks that you want, aren't available, right? So now you have to get a little bit more creative. But the reality is it's just numbers, right? Whether they map directly or not, it might make your dial plan a little bit more complicated. So instead of creating like one kind of generic mask that says, okay, take all of the 408-555 numbers and strip off the 408-555, and that becomes the extension, right? And you could do that for your entire enterprise. That would make it very easy to identify a pattern that would do that, a translation pattern that would do that. But if that's not available, you might have to start now setting up individual translation patterns for every single user, or at least for a subset of users. So you might have multiple blocks of DIDs, and then you have to set up multiple translation patterns to handle each of those unique scenarios. I mean, I have seen in all my implementations so many different scenarios where you have these different types of manipulations. Typically, and we have some customers that say, you know what, I don't want any of my endpoints to be reachable from the outside. So we don't need any DID extensions. We don't have a need for DID. So that obviously makes your life a lot easier in that particular case, because you don't have to plan for that. But most times that's not the case. Most times you're going to have some sort of DID function. So there are, there's the book kind of defines 2 types of dialing. 2-stage dialing would be where you dial like an auto attendant, and then from the auto attendant you can enter the extension of the person that you're trying to reach, and then based on that, the call will get routed to that individual. That's what we refer to as 2-stage dialing. And then you also have direct inward dialing, where you can just dial the extension directly. Certainly with like fax machines and in certain scenarios, the DID option is really the only option. 2-stage dialing doesn't really, or two-phase dialing doesn't really work very well with fax machines, but a lot of companies do like to have that DID dialing experience. All right, the E.164 number would be used for the PSTN. That's going to start with the country code, like I said, 1 to 3 digits, and then you're going to have a 12-digit subscriber code. That's the general format. They define it as a 15-digit number, which it is. E.164 is defined as a 15-digit number, but it is broken down into the 3-digit country code. With a maximum length of 15 digits, inclusive of that country code. All right. So in the case of this particular diagram, we're seeing this 1-to-1 relationship between the DID number and the internal directory number that's assigned to the phone. That would be ideal, of course. All right. Now, what if I'm doing endpoint addressing based on a URI? The URI, this isn't that common. The URIs are not actually assigned to the phone line. They're assigned to the directory number. The directory number is still assigned to the phone, but then we have the ability to reach that destination by that fully qualified URI format or some sort of, not fully qualified name. So just JDO or the fully qualified name, JDO at cll-collab.internal. All right. The URI format is like an email address, and you can actually place calls to URIs from endpoints that actually support URI dialing. That would typically be through some sort of application, right? Not a keypad, obviously. But again, we don't really see this concept of URI dialing too much. We do see it actually if you guys work with video conferencing solutions and telepresence solutions, you will see URI dialing a lot more in those types of scenarios than you would in a traditional phone system. All right. All right. How does the URI relate to the endpoint addressing in Call Manager? It is a number that is translated to a directory number. It is not a number. It has no relationship with the endpoint. That's not true either. I have a feeling that A is the correct answer. Well, actually, no. C actually makes sense. It's an alias that then gets mapped over to the directory number. That's exactly what it is. It is an alias that gets mapped over to the directory number. And that alias is in the form of user@domain.dom, right? And it is absolutely supported in Unified Communications Manager. Now, how does Call Manager handle call routing? Calls have to be routed based on the number that you dial, right? Just like when you're doing routing in a network, based on the packet header and based specifically on the destination address in a routing table, I make a decision on how that packet is going to get routed by looking up information in my routing table. What's the same thing in a phone system? Essentially, the dial plan is the routing table, and I make a decision on how calls are going to be processed by the phone system based on that routing table, which is our dial plan. We see here that there are basically, 4 blocks, right? The local endpoint and the intermediate call control function. So that's the local endpoint is the one where you're going to be placing the call and facilitating the keypad to dial the digits. Call Manager acts as our call agent. So Call Manager is the one that's going to house the actual dial plan. And then we have our destinations. A destination could be a trunk, a SIP trunk, or an H323 trunk. It could be a traditional PSTN gateway, like a PRI or a T1 CAS circuit or something like that. Or the destination could be, another locally attached endpoint. It doesn't necessarily have to be, outside of the system. But in any event, we still have to be able to route that call. All right. So we have to be able to, based on the digits that are collected, as the person is dialing the phone number, based on those digits that are collected, we have to make a decision as to how we're going to route the call. And there's actually 2 ways that we collect digits within Call Manager. We can do end block dialing, where we wait for the entire number to be collected, and we make the call routing decision based on the collection of all the digits, or we can do best match routing on a digit by digit basis. We'll talk about the scenarios and where you see one versus the other a little bit later on. All right. Now, when it comes to dialing or passing calls through a phone system, we have intra-site calls. Intra-site calls are calls that are routed within a single site. We have inter-site calls. These are calls that are routed from one site to another. And I'm not talking about branch 1 to branch 2. I'm talking about Call Manager Cluster A to call manager cluster B in this particular case. So we're actually routing from one call control agent to another call control agent. Or we can do PSTN routing, where we're actually sending the call over the PSTN and then obviously routing the call to the service provider based on that PSTN routing function. So lots of choices for routing calls over outside of the phone system. Call manager routes calls to internal destinations within the same cluster fairly easily, right? Because these are all endpoints that are actually registered inside that cluster. We're able to identify those endpoints very easily. It'd be kind of like saying these are directly connected networks on a router. By default, a router is aware of all the directly connected interfaces. As long as the interfaces are up and running, the router is not going to have any issues reaching those particular destinations. We don't have to have any kind of logic, either static logic or dynamic logic, built into the router to be able to route to those directly connected networks. All right, but if we're doing intersite or we're doing PSTN dialing, then we have to have some sort of logic built into the system that allows us to route those particular calls. But regardless of how the call is being routed, the call process is kind of identified in this diagram right here. Call manager receives the call setup request from the local endpoint, whether it's a skinny endpoint or a SIP endpoint, or even a call that's being processed by another call control system, like a PSTN gateway or a different call manager cluster. Call manager analyzes the target of that received request, because that's how we're going to decide how the call gets routed based on the target information. And we look at our dial plan. Now, there is one slight difference here than we have with routing. In routing, we don't typically worry about whether or not the packet is allowed to be routed, at least not within the general function of routing, right? We could have access control lists and different kind of secondary security policies in place that would disallow a packet from being routed, or it would filter the packet. But in the case of call manager, we need to be able to identify if that call is allowed to be routed based on the class of restriction on that device. And every single device will have class of restrictions defined. It's very, I know in our labs and our discoveries, we haven't really looked at that. And pretty much in the discovery, everybody can dial everything because we're putting everything in the null partition and the null search space. But that's not typical in most call manager environments, or even most phone system environments. We are actually kind of restricting what, how calls are allowed to be made. So that's one of the additional steps that call manager is going to do. It's going to identify whether or not the call is even allowed to proceed. Now, once we've decided that that call is able to proceed, the next step would then be to do the analysis of the digits. Like I said, we can do digit by digit analysis, or we can do N-block, E-N-B-L-O-C analysis, where we're analyzing the digits as a whole. It doesn't really matter if we're doing digit by digit or N-block. The end result is the same. The call is either routed or not routed based on the ability to match it to some sort of rule that we have defined within call manager that says we're going to go ahead and route this particular call. Does that make sense? All right. So that's kind of the next step. We analyze the number. We look at our forwarding information. We decide that we're able to forward the call. And at this point, we decide, okay, this is going to go to this gateway. It's going to go to this trunk or whatever. And then we may decide to do some additional things like manipulation of the digits, stripping off digits, adding digits, expanding the number or whatever. And then we send the call to the system. All right. So depending on what type of call it is, will also depend on whether or not we're managing the physical layer and the data link layer function of that call as well. Obviously with IP telephony type of calls, we don't really worry about that. It's mostly about just getting the call onto the trunk and then sending that on its way. But if we're talking about a PRI, we have to seize a channel. We have to signaling functions that we have to provide. We have caller information that needs to be provided as well, especially to the PSTN. The service provider has very specific requirements on how a call is represented, with maybe like an ISDN type. Is this an international call? Is it a local, a national call, that kind of thing, and so on. We'll get into that a little bit later on as well. All right. Who can actually place a call? Well, certainly IP phones have the ability to place a call. Obviously, IP phones are kind of the primary source of calls that are being placed on the system, but there's other ways to source a call. A trunk, for example, can actually place a call. It can't actually physically dial the number, but it could be the source of a call. So, for example, let's say I send a call over to Unity. Unity is my voicemail platform, but it's also the platform that I use for a lot of my auto attendant features. And somebody's going through an auto attendant in Unity, and then based on their selection, that call is being routed to the PSTN. Maybe they picked option 3 or option 4 that says, route the call to this external partner that we use for this function. Like you said, James, we're talking about answering service, right? Well, the trunk in that case then becomes kind of the originator of that call, because the call was already processed through the auto attendant, and now the trunk is the one that's actually sending that call to the PSTN. Gateways can also be the source of call routing requests. Inbound calls certainly come into a gateway, and then based on a DID number or based on a number that's dialed, that call needs to be routed to an endpoint. Voicemail ports, when we're doing message waiting indication, that's actually an outbound call. When we're trying to, if somebody dials into the voicemail system and they need to communicate with that voicemail system, we can use ports to do that as well. So it's not just a phone that is going to be the source of calling information. And the reason why that's important to understand is that oftentimes people will set up class of restrictions on the phones, but they won't end up setting up class of restrictions on their trunks or their gateways. And then those become the points that toll fraud occurs, because we didn't consider that we need to limit the ability of a trunk to dial, or we need to limit the ability of a gateway to dial from the phone system. It's a pretty important concept. All right. A translation pattern, as the name implies, is a way for us to manipulate numbers. Translation patterns can actually, they have an inbound and an outbound function. If you think about what the purpose of a translation pattern is, I'm receiving a number, I'm translating that to another number, and then I'm forwarding the call on. So that is the source of the potential source of a call, a translation pattern. There's also what we call transformation patterns. They're a little bit different. Transformation patterns are used just to manipulate numbers, but they're not actually used to connect calls. So there's basically two roles in a translation pattern. We have the inbound function by matching a pattern, and then we have to translate it, and then we have an outbound function by call routing, basically routing that call through the pattern or through the translation process and sending it on to its destination. All right. The call routing entries that go into the database in Call Manager. We have directory numbers, or DNs. Those get assigned to our phones. We have directory URIs, which are the aliases that allow us to map over to a DN. We have route patterns. Route patterns are typically your outbound patterns, like your PSTN dialing patterns that you're going to use to route calls. Directory numbers usually get assigned to phones. Directory URIs get referenced to directory numbers, which are assigned to phones. Route patterns and SIP route patterns usually point to some gateway, either through a media resource group list or directly to the gateway. But the idea of route patterns is these are the patterns that I'm defining in the system that allow me to dial out to the PSTN. A translation pattern is basically just a pattern that allows me to take a received set of digits and translate them to a different set of digits so that I can proceed with the call. A hunt pilot is a That call hunting scenario that I described before, you dial this extension, and then that extension answers the call. It could go through some sort of auto attendant, or it could just ring a bunch of phones. That's typically what call hunting is. Call park numbers. This is the first time we've seen that. Call park is a way for us to do call handling. So let's say somebody calls Bob, and Bob's not there, but somebody answers the call. And they say, well, yeah, I'd like to talk to Bob. Okay, well, Bob's out on the sales floor. So now I could put the call on hold and go tell Bob I put a call on hold on your phone, and Bob has to walk away from the sales floor and go to his phone and pick up the call. All right, that would be traditionally how we would do that. But in Call Manager, we have the ability to park calls. So we set up these park extensions, which are just basically directory numbers that are reserved for this feature. And I push the soft key, the park soft key, and it puts that call on hold, and it returns on the screen the directory number that call is being held at. And then I go over the loudspeaker, or I call Bob, and I say, hey, Bob, you have a call parked at extension 500. Bob can then go to any phone, dial that extension, and the call will be connected to that particular phone. So it's a way for us to kind of handle, transferring calls and putting calls on hold and so on. The Meet Me function is like a kind of an ad hoc conferencing function. Well, actually, technically, it's not considered ad hoc. Ad hoc would be where you call one person, put them on hold, call another person, and bridge the call together. Meet Me is like a bridge, a dial-in bridge that you can dial into. It's a very basic conferencing function that Call Manager has, to do basic conferencing. So you have a Meet Me number, and you just say, okay, everybody dial into this number, and you'll be automatically joined to this particular bridge. Oh, not a whole lot of security in that, but it is a basic conferencing function. All right. Which phrase describes the call routing process? Which phrase describes the call routing process? Is it finding an entry in the call routing table that matches a dialed number? Sounds about right, actually. Finding an entry in the call routing table. The Dow Plan, right? A couple of you guys were going through the discovery, and you had some issues, or we had some troubleshooting things that we had to take care of. And the first thing I asked you guys to do was go to look at your route plan report. On the second menu in the Call Manager administration page is all of our Dow Plan configuration. Partitions, search spaces, directory number configurations. Everything is done under that specific submenu. And one of those options is to do a route plan report. A route plan report basically provides you a list of all of the directory numbers, all of the numbers that are assigned, created within Call Manager. It doesn't even have to be a directory number. It could be a route pattern. It could be a directory number. It could be a pilot. Any phone number that's provisioned in the system will show up under the route plan report, and then you can kind of see how that particular number is associated. Is it associated to a phone? Is it associated to a CTI route point? Is it associated to a hunt pilot? Those kinds of things. But that's what they're defining in this case as the call routing table. So that would be the applicable answer here. It doesn't choose the device to which the call is sent. That is an element, I guess, of call routing, right? Is the phone going to ring, or is we going to send the call to a gateway? But that's just part of the call routing process. Finding an entry in the call routing table that matches the calling number. No, we don't route calls based on who is calling. We route calls based on what number was dialed. Obviously, that makes sense. Sending voice over IP RTP packets toward the destination. No, that's not the responsibility of call routing, right? We're not generating the packets. We're just simply directing the packets to their destination. All right, so the answer in this case is A. So how does Call Manager handle call routing logic? the way we match a particular number. So when I dial a number, Call Manager uses what we call closest match logic to choose the matching pattern. It's almost like the concept of longest match routing. When we talk about routing packets to a router, and we're comparing a packet to the different entries in the routing table, whichever route entry has the longest prefix length is the one that we're going to use to route that particular packet. It's the same kind of concept here. It's not quite the same, although it is very, very similar. We're not using subnet masks, obviously, in this case, but we're talking about how many possible combinations of numbers does the resulting pattern generate. So like a 12xx will generate 100 different possible combinations, whereas a 121x will generate 10 different combinations, 1210 through 1219. Does that make sense? So the closest match, if the number starts with 12, would be, and just comparing those two, would be the 121x, because it has the fewest possible resulting matches. All right. In other words, it's kind of like what we would define in routing as a longer match. So Call Manager uses this closest match logic to choose the pattern that it's going to match to when it's going through the process. Now keep in mind, we are talking about patterns that fall within the scope of the phone's calling search space. We're not matching every single pattern in the system. It has to be a pattern that's listed in the phone book that is assigned to that phone. We never look outside of the search space. So again, if the pattern isn't part of the search space for the phone, it's not going to be referenced in matching the rules. So again, a calling search space is essentially a list of partitions. The partitions are the phone books, and the patterns themselves go into those phone books. So if phone A has search space 1, and search space 1 has partition 1, 2, and 3, but the pattern happens to be in partition 4, we're not going to match against that particular pattern because it's not part of the phone books that particular phone has access to. If you have multiple potentially matching patterns, the destination pattern that gets chosen is based on the pattern that matches the dialed string. All right. Now that would be an exact match, right? So if somebody dials 1, 2, 3, 4, then we're going to match the pattern of 1, 2, 3, 4, assuming that pattern is part of my search space. If it doesn't match a specific string, then in that turn, it's going to be matched against whichever one has the smallest number of returnable values, right? They call them endpoints, but the reality is it's just basically the smallest number of returnable values, because just because an extension, a range of extensions is created doesn't necessarily mean that it's actually assigned to an endpoint. So we're not going through and saying, okay, this pattern has, there's 99 different patterns here and 10 of them are assigned, but there's also 99 patterns here and 15 of them are assigned. We're going to go ahead and use the one with 15 assigned. No, it's just basically based on the total number of matches. An X in a pattern within Call Manager is a single digit, 0 through 9. So 12xx is going to match 2 wildcard digits, which means that we have 100 possible combinations, 0, 0 through 99. All right, that happens to be a test question, by the way, as well. So if a call is routed, if somebody dials 1200, 1200 happens to only match the 12xx pattern. But if somebody dials 1210, it matches both the first and the second pattern, but it would actually get routed to the second pattern, regardless of, by the way, the order in the search space. Search space is an ordered list of partitions, and we'll get into that a little bit later on. But the search space is an ordered list of partitions. We always do closest match. So even if I search the other partitions, I'm going to do that closest matched routing. Now, if there's overlapping pattern matches, then I would use the first available one in the first partition. So if I had a 121x pattern in partition 1, and I had a 121X pattern in partition 2, and both of those partitions were assigned to the search space, and partition 1 happened to be the first partition in the list, then I'm going to go ahead and use that pattern. I'm going to go ahead and match to that particular destination. I wouldn't go down the list and because there always has to be some sort of tie break, right? So we can see here if somebody dials 1234, that's only going to match one pattern. If they dial 1212, that's only going to match, well, that matches actually two different patterns, and we would match it to the longest match. All right.
I have a question.
Yes, go ahead.
How granular can you be with that? So can you do 1, 2, 1, 0 through 5, and then 1, 2, 1, 6 through
Yes.
9?
Yes, you can. We'll get into creating patterns a little bit later on, but let me give you a couple of examples. So let's say, for example, I have a pattern of 9.911. Now that's a typical pattern that I would define in the system. 9 being the PSTN access code. The dot in this case doesn't represent a wildcard. It's a distinguisher between the access code and the actual number that you're dialing. So we do something called pre-dot discard, where we can actually drop anything before the dot, which would be the access code, and then we can process the call. So that's a typical pattern. 911 is another typical pattern. You might have you could certainly do a 7-digit pattern that looks like this, XXX, XXXX, but the problem is that is too generic. It matches, we would have so many overlapping numbers. I mean, think about even if we just had 3-digit dialing, three-digit extensions. Now you could fix that problem potentially by doing a 9 dot and then making sure none of your internal extensions start with 9. But you'd want to try and make the pattern as specific as possible based on standard North American numbering plan rules. And that states that this first number would never be a 0 or a 1. All right, so I would create a pattern like that to make it more specific. So the brackets indicate a single character, and then 2 through 9 is the range of what that character can be. So the first digit can be a 2, a 3, a 4, all the way up to a 9. And then we follow that with 1, 2, 3, 4, 5, 6 wildcards to indicate the 7-digit number. All right. The reason why this would be bad is because guess what that overlaps with? That overlaps with 911. But this does not overlap with 911, right? And that's why, by the way, they have that restriction that we can't have a 0 or a 9 or a 0 or 1 in the pattern. So you can get pretty creative. This isn't. We don't use regular expressions in Call Manager. We use regular expressions in iOS-based gateways that do call routing. But in Call Manager, we just have a subset of wildcards, which we will see later on, that we can use to define different patterns. Another example of a pattern would be a 10-digit dialing pattern. So 2 through 9, XX, 2 through 9, XX, and then 4 X's. And by the way, it does have to be an uppercase X. Believe it or not, it's actually case sensitive. The lowercase x doesn't mean anything. Just Call Manager looks for the uppercase X. So that would be a pattern. You could have something like 9.1 and then your 10-digit number if you're doing 11-digit dialing. These are all typical patterns that you would set up in the system, right? If you wanted to do toll-free, of course, these would handle toll-free. But some people like to classify the toll-free numbers separately because these patterns are typically toll-based patterns, and 888 numbers, 855, 866 numbers, 800 numbers, those are not toll-free. And then you have to get even more creative. If you go out and look at the actual North American numbering plan, it is something you need to be concerned with. let me show you what I mean by that. So let's say I go out here and I say, show me the North American numbering plan. All right. And I look at the images. Guess what? North American numbering plan doesn't just include the United States. It includes obviously Hawaii. It includes Canada. It includes a whole bunch of these Caribbean locations as well. So now you have to start getting into, well, do I want to be able to allow people, if I just have a pattern, let me go back to my list here. If I just have this pattern, that includes Caribbean numbers and Canada numbers and so on. So now I have to start getting creative and saying, okay, let me define what all of those what falls within that North American numbering plan. And then I have to decide, okay, am I going to block those particular area codes, right? So let's look at the list here. So obviously we have the American ones, but if you look at, for example, 250 is Canada, 249 is Canada. The ones that we're most concerned with, though, are the ones that go to the Caribbean, right? Remember that whole scam back in the day where you would dial a number in Jamaica and you get a bill back of like $25 a minute or something like that for that call, it was basically, it looked like a regular long distance call, but it was actually going to the Cayman Islands, or it was going to Jamaica or something like that. So you have to be concerned about that. There's actually a document that the FCC publishes that talks about what area codes you should block, unless you have a specific reason for calling those area codes, but you should treat them like international numbers, basically. I know that was a little bit beyond what you were asking, but hopefully I answered your question. You don't have a whole bunch of flexibility, right? We're not using regular expressions, so we can't do things like the number starts with, or we're going to exclude this number, or we're going to include this digit or exclude this digit, like we do with Call Manager Express, where I can use actual regular expressions. But we do have some wildcards that we can use to define the numbers that we're using, or the numbers that we're matching in Call Manager. All right. All right, how does Cisco Unified Communications Manager route the call if multiple potential matches are available for a dialed number? It chooses the patterns that match. No, it doesn't choose all of them, right? It has to choose one pattern. We can't choose all the patterns that match, obviously. It chooses the pattern that matches the dialed string and represents the smallest number of endpoints. The smallest number of matches, I would say, is probably a better way of saying that. But yes, that would be the correct answer. It chooses the pattern that matches the dialed string and represents the largest number of endpoints. That would be the opposite. It stops the call routing process and rejects the call. And by the way, just because we're able to choose a pattern doesn't mean that we still don't have post-dial delay, right? There's something called a T302 timer, and I'll just pull that up here because they do ask you about it on the exam. A T.302 timer, which is, I don't know if they have it listed here. It could be just a Cisco thing. Let me do a Google search. T.302. I thought it was a standard, but this is a T302 timer. I put a dot in there, maybe that's why. But it's how long we wait if we have an overlapping number before we decide that the call needs to be processed. All right. And there's some questions. This question actually comes up because there's a couple of test questions about what the actual default T302 timer is. It used to be 10 seconds. And obviously this is really old, Call Manager 3.3. But I think now, I'm almost positive now that it's 15 seconds. That is an adjustable value. So yeah, see here, call takes 15,000 milliseconds to route. That's the standard T302 timer now, 15 seconds. All right. And we'll talk about urgent priority and how we handle that with 911 a little bit later on. But Andy, I hope that answered your question at least. All right.
Yes.
Okay, good. All right. Oops. Now, there are other ways to handle how Call Manager does the digit collection. Digit collection seems like a basic concept, but it is really, really critical in how we analyze the Dow plan because Call Manager is going to behave differently depending on how the digits are collected. And digit by digit is one option. N block is another option. KPLM is another option, and so on. So we can kind of see here in this graph a representation of how digits are collected. In SIP, for example, we can use N block dialing. N block is a really simple concept. We're going to wait until all the digits have been entered, and then we're going to make a decision on how to route the call based on that. When I'm doing digit by digit analysis, I'm collecting a digit, I'm matching it against all the partitions and all the patterns, and I'm kind of eliminating patterns until I finally get to the point where there's only one matching pattern, right? N block is, I mean, we're basically doing the same thing. We're just waiting to collect all of the digits before we make that decision. The KPLM, KPML process is a little bit different. It's still a way of collecting the digits, but it provides us a way of analyzing that information, that keypad markup language. This is only going to be available with SIP, obviously, as the document or as the diagram describes here. But KPLM matching is a form of N block dialing as well. The whole digit string gets sent in a single SIP invite message. And then with N block, excuse me, but with KPLM, the digits are sent one by one. So it's kind of like the same concept of doing digit by digit analysis in a skinny phone if it's not a Type A phone. Type A phones are the kind of the older phones. The Type B phones are the newer phones. 7905, 7912, 7940, 7960 are considered to be Type A phones. Type B phones are kind of the more modern phones, I guess. They're the ones that are going to do the N block digit analysis as opposed to the digit by digit analysis. All right. Not that that's something you need to know for the exam, but so KPLM is kind of what it gives us the ability to do that digit by digit analysis by sending each of those individual digits one by one, as opposed to sending the whole dial string in a single SIP invite message. SIP dial rules get processed inside of the SIP phone. So the SIP phone can actually detect invalid numbers. It can play Enunciator messages like a reorder tone, that fast busy that you hear. And it doesn't even have to interact with Call Manager to be able to do that if the dial rules are actually installed on the phone itself. If the dial digits match a specific dial rule, then we can send an invite message to Call Manager to say, okay, I'm ready to now go ahead and process this call and proceed with the call setup and so on. In KPLM, we can use KPLM to send the digits one by one. It's not really that critical that we understand necessarily how we're implementing this in our system. In fact, it's not something you would typically change unless there's a very specific requirement that says we need N block dialing or we need to do digit by digit analysis. It will change, however, how the call is processed based on that collection method. So that's very, very, very important. All right. In fact, they have a couple of examples here. Let me just kind of summarize this chart here as well. So we can see for IP phones with SIP, we have N block dialing, we have KPLM, Well, we have SIP dial rules. KPLM is not going to be supported on those older phones. SCCP, we have digit by digit analysis or en block dialing. With the gateways, if it's an MGCP gateway, a SIP gateway, or H323 gateway, we have en block, and we have something called overlap sending and receiving. I'll talk about that in a little bit as well. I want to kind of get through the rest of this, and then with our trunks, our SIP trunks or our H323 trunks, we have en block or overlap sending and receiving. So, I don't know that this is going to be on the exam or not, but it is something that you might want to kind of confirm to memory there because it could be something they could ask about. All right, so let me talk about a little bit about what overlap sending and receiving is. Overlap signaling means that the dialed digits are sent one by one as they're received from that particular calling device. This is typically something that we would see with a trunk, like an ISDN trunk or a SIP trunk, but the first digit gets sent. It's going to be sent in the initial call setup message, and then each additional digit that gets pressed is sent in what we call informational messages that follow that. If we have variable length phone numbers, if we're not using a standard numbering plan, overlap signaling is going to be something that is something that we would probably want to use. And receiving would be the same thing in the opposite direction. All right. So it's just a way again of how we handle the digits, how the information is exchanged. Overlap sending specifically means that call manager is going to keep collecting digits as they're dialed, and then it's going to pass them on to the PSTN as they're dialed. And in call manager, there's a checkbox that you can do in the when you're establishing the configuration of the route pattern, where you can actually just check the box that says allow overlap sending as part of the pattern. All right. Again, not something we typically change, as part of our configuration. It does depend on the telco. Like I said, some telcos might not have the capability to handle numbers that are sent in en block mode. So you have to turn on that overlap sending and receiving function. It's really not being used a lot in the US. Maybe with an old T1 CAS you might see it, but in Europe and Asia it's obviously, I wouldn't say obviously, but it is more prevalent. All right, it just really depends on the phone company, and oftentimes they will tell you whether or not they need it. Germany, for example, I know we did an implementation a couple of years ago in Germany, and they required it. The particular service provider that we had required it. All right. Let's talk about the digit by digit analysis. Here we have call manager. We know call manager doesn't receive all the dial digits at the same time in this particular case. So this is kind of what I was describing previously when I said call manager is going to go through the process of searching through the search space and then eliminating patterns as it receives additional digits. So initially we have these 4 patterns that are available within our search space. If I haven't received any digits, then all patterns qualify. Once I receive the 1, that's going to eliminate the 2000 pattern because it doesn't match. Then when I receive the 0, it's going to eliminate the 11XX pattern because it doesn't match. I receive another 0, it still matches the 1XXX and the 1001 pattern, and then I receive the final 1, it still matches the 1XXX and the 1001 pattern, but 1001 is a better match because it has the fewest possible matches. All right. If you do send the digits one by one, call manager starts that digit analysis as soon as it receives the first digit. All right. So that does take that takes processing cycles and and requires us to go through the process of matching those digits against the partitions in our search space. All right. Call manager doesn't always receive one by one. We saw that up here in this example. We could have N block for type B phones. We could have N block if it's a SIP phone. So in that particular case, obviously we're going to go ahead and just do the analysis based on the how the number was received. In the end, it really shouldn't matter. We should still end up matching the same set of patterns or the same pattern, and the call should still be routed the same way, but it's just something to keep in mind. All right? Which of the following methods... Yes, go ahead.
Hey, sorry to interrupt. So would that be similar to off-hook and on-hook dialing?
No.
Okay.
Yeah, I understand what you're saying, right? So on-hook dialing, you dial the whole number, you pick up the handset, and then the call gets dialed. That would not change how the call is processed by call manager. It's just a way for you to do like an edit dial. If you misdial the number, you can delete the number and put in the right number and so on. But if you're doing digit by digit analysis, the digits are going to call manager faster, and call manager is analyzing those digits faster, but that doesn't mean you're doing N block dialing in that case. It would actually have to be how the phone is actually configured to identify whether it's doing digit by digit dialing or N block dialing. Okay. All right. Which of the following methods of digit collection is supported by skinny phones? Well, it's funny they asked that because when we looked at the SCCP configuration, it was digit by digit was one of those options. So that's the answer in this case. Because N block is not listed here, that's not one of our choices, but that would be the second choice. KPLM is supported by SIP only, and overlap sending and receiving are my gateways and trunks, and SIP dial rules would be my SIP endpoints as well. All right. All right. So how do I handle variable length patterns? How do I handle overlapping patterns? There are scenarios, and I'll go back to this scenario, where we have maybe a pattern that needs to match an international number, right? So we might be able to define a country code, and we might be able to define a North American number easily, but how do we define the individual subscriber codes that exist around the globe? There's no specification on how long those subscriber numbers have to be, and there's no way to really define, how long those numbers are. So for my international pattern, I might have like a 9.011. That would be my typical pattern I would use to get for international dialing. But then what do I do after that? If I just leave 9011, that means that basically that's the number. I'm dialing 011. But there is a wildcard called the exclamation point wildcard, which basically matches any variable length pattern. It's not 15 digits, it's not 5 digits, it's any digit. All right, so if I do a 9.011 exclamation, this is what I would use typically for my international dialing pattern. The only problem is we have that T302 timer, that interdigit timeout, that comes into play in this particular case. All right, so I could do like this, a 9.011, and put in the pound sign. The pound sign is actually defined as a termination key. So I can tell people, well, if you're dialing internationally, you don't want to wait for that 15-second timer to go by, go ahead and hit the pound sign at the end, and that will tell call manager that you're terminating your dial digits, and it can go ahead and place the call. All right. So there's several different ways that we can actually handle these different kind of variable length patterns and wildcards. You just kind of have to get used to them as far as what wildcards are available and what they represent. The exclamation point wildcard is just for any kind of variable length pattern. It's 1 or more digits following the exclamation point. It's not 0 or more, it's 1 or more. All right, but that T302 timer, 15 seconds listed here, that inter-digit timer is going to come into play. Like I said, we can use the pound sign to indicate the end of dialing, and that pound sign is specifically reserved for that purpose within Call Manager. We understand the issue, right? The international dialing destinations have variable length patterns. All right, so in North America we use 011, for example, to do international dialing. In Europe they use a 00 to indicate international dialing. So even those rules are kind of different depending on the region that you're at. All right, I think you guys basically understand the concept of a T302 timer. That is a configurable value. You can go under service parameters and go to Call Manager and go to cluster-wide parameters, and you can adjust that T302 timer. You can make it longer or you can make it shorter. The problem with making it shorter is it does decrease the post-dial delay, but if you have some slow dialing person, then all of a sudden the person, the call keeps getting connected, because they're just slow at dialing, and then the call keeps failing because they're not getting enough digits or whatever. All right, so that interdigit termination or the interdigit timeout termination key is very, very useful in these kind of patterns that have variable lengths and so on. All right. If you have overlapping patterns, and it is possible, you could have overlaps occur that don't actually involve long distance or international patterns. Here we see 141 overlaps with 1, 2 through 4 XX, and 131 overlaps with 1, 2 through 4 XX, and with the 131 exclamation point. So we try to avoid this as much as possible, obviously. But there may be scenarios where, you can't get away from that. So you have to wait for interdigit timeouts when you're dialing 13115 or 131 or 1415. Now 1415 doesn't necessarily match, the 131 patterns. But it does match the 141 and the 1, 2 through 4 XX. Now 141 is a 3-digit pattern. If I'm dialing 1415, that's a 4-digit pattern. So it knows I'm no longer dialing that 3-digit pattern. But you get the idea. The idea is that we need to make sure that we've designed our dial plan to eliminate these overlapping patterns as much as possible, because our goal is to reduce the post-dial delay, make sure that dialing occurs as quickly as possible. Another concept that exists within Call Manager is something called urgent priority. There's a checkbox when you define a route pattern or a translation pattern or even directory numbers that says I'm going to mark this number with urgent priority. Urgent priority means that I have to process the call immediately as soon as I see those digits. Okay? So I would mark 911 with urgent priority. Now that also means that there can be no other patterns in the system that have 911 or overlap with 911. We would never be able to dial them because the urgent priority pattern would always be matched regardless. So when I'm creating my 911 pattern, so for example, let me go back to this list here. This pattern here overlaps with this pattern, overlaps with this pattern, overlaps with this. Actually, it doesn't overlap with this pattern because we did it correctly. If this was an X, it would overlap with that pattern. If this was an X, it would overlap with that pattern. Again, that's the reason why we would use the 2 through 9. But if I mark this urgent priority, right, when I define the pattern itself, what the heck happened there? Urgent priority. If I mark that urgent priority, then that means as soon as I dial 911, this pattern is going to get matched. That obviously causes a problem with these patterns. which means I can't actually dial those patterns anymore. That's why you need to make sure that the patterns are as specific as possible. So in our North American numbering plan, they define that the first digit of a 7-digit number cannot be a 1, and the first digit of a 10-digit number cannot be a 1. Now, is urgent priority required in this case? Not necessarily, right? Because we now 911 doesn't overlap. But what about 9911? That does overlap, doesn't it? Right? So 9911 could match this pattern, 9911 can match this pattern, so I might decide to mark that one urgent priority as well. Then I have to consider, okay, what is the effect of that on dialing 900 extension, 900 area codes and so on. So just a lot of different things to consider when you're talking about the Dow plan. All right. So, if you have a pattern that's marked with urgent priority, it's going to force that immediate routing of that call as soon as the match is detected. We're not going to wait for an interdigit timeout to expire, and we're not going to assume that there are any other longer potential matches. So you need to be careful as to what you define as urgent priority as well. By the way, translation patterns are automatically marked as urgent priority. So be careful with that as well. When you define a translation pattern in the system, the urgent priority checkbox is automatically checked. All right. How can a user shorten the T302 timer? Oops. Sorry about that. How can a user shorten the T302 timer when calling a number that is located in a country with a variable length numbering plan? We press the pound sign. It has to be defined as part of the pattern, though. It's not inferred. So you have to have a pattern defined with the pound sign in the pattern to be able to use the terminating key. All right. All right, that brings us to discovery number 11, implementing endpoint addressing and call routing. In Discovery 11, implementing endpoint addressing and call routing, we're going to talk about deploying endpoints and, of course, setting up our Dow plan. In Unified Communications Manager, you can configure phones with 2 endpoint addresses. One of those addresses is a directory number, and the other is a directory URI. The configuration of these addresses is, quite similar, but there are some differences between them. Each type has different kind of characteristics that you are going to become familiar with as we go through this particular discovery. There is a call manager, obviously, in this particular configuration, HQ, CUCM. We also have 3 different CIPC phones, CIPC1, CIPC2, and CIPC3. We're going to configure directory numbers on these phones. We're also going to identify how the directory numbers differ from the line appearance. And then we're going to apply directory number-based URIs and user-based directory URIs for the phones as well. The last thing we're going to do is configure overlapping directory numbers and analyze the related problems and what the role of urgent priority is going to be in our particular topology as well. So we have 3 PCs, 5.200, 5.201, and 99.101. That's going to be PC number 3. We also have an Active Directory server that's not documented here, but that's going to be our 5.100. So in our first task, we're going to perform the initial configuration. Now the Dow plan is already configured. We have some pre-configured endpoints as well. We just need to go into those endpoints and make sure that they have the correctly provisioned CUCM configuration, like we've done on many of our discoveries up to this point. So let's go ahead and go into PC number 1 first. And on PC 1, we're going to go ahead and authenticate. And we're going to set up IP communicator with the appropriate settings, pretty much like we've done just about in every discovery up to this point that's involved the use of these IP communicator applications. All right, so we're going to right click, let's go into preferences, go to network. We're going to go ahead and change the name of this device. Oops, sorry about that. We're going to change the name of this device to CIPC-1. It already has the appropriate TFTP address, and then the device will restart. It's going to, of course, boot up, convert to SIP, and then everything will be fine on that device. Let's do the same thing on PC2. In the case of PC2, of course, we're going to set up that IP communicator as CIPC2. All right, and then we'll do the last thing on PC number 3. We'll go back and then confirm that all of these devices are in fact registered, and then we'll move on to configuring our Dow plan. So this device is going to be CIPC-2. -2. All right, that device will reboot and hopefully register. And then we'll do the same thing on device number 3. And this one is actually going to have pretty much the same, even though it has a different IP address, it's still going to route to the same TFTP server. This one's just going to be CIPC3 in this case. All right. We can already see that CIPC1 has booted up. CIPC2 hasn't quite booted up yet, but we'll check that in a minute. This one's taking a little bit longer to boot up. I'm not sure why. Let's go ahead and check CIPC2. Looks like it's in the process of registering. It's going to do one last reboot. Not sure why this one's not booting up just yet. There's CIPC1, CIPC2, finally booted up, and then we got PC number 3 here. So let's go ahead and change this to CIPC-3. Again, these phones were already provisioned in Unified Communications Manager. Oops, I forgot to change the TFTP address. Let's modify that configuration again. I might have to wait for it to reset here. All right, that device is now rebooting. It's going to download its configuration. In task number 2, we're going to discuss and look at the differences between directory numbers and line appearances. In Call Manager, a directory number is an independent component within the Call Manager database. Once the directory number is associated with the device, that device record in the Call Manager becomes the directory number. That's essentially, by definition, how we identify that line appearance within Call Manager. It's important that you understand the difference between a directory number which is not associated to a device and the directory number which is associated to a device. And that's what we're going to be taking a look at in this particular case. In the activity, we're actually going to take a look at the difference between directory numbers, shared lines, and line appearances. A single directory number can be associated with no devices if you just want to establish the directory number configuration and your Dow plan configuration, or it can be associated to multiple devices. If that directory number is actually used with multiple devices, it's called a shared line appearance. The directory number configuration actually consists of a couple of different parameters. We have all of the directory number parameters that are shared with all of the associated devices, things like calling search space, all the call forwarding settings that might be set on that device. And then we have directory number parameters that are associated with a specific device, things like line text to label, external phone number mask, and so on. We can actually go into the directory number configuration in a couple of different ways as well. We can view and edit the shared directory number parameters if we go into our call routing submenu and then go into the directory number submenu. Any changes that are made to those parameters are going to apply to every single device that that directory number is assigned to. If we want to view and edit the shared and the device associated parameters, we need to choose the line configuration link at the phone configuration page and then say edit line appearance from that directory number configuration page. And then depending on what parameter is being changed, that parameter might only apply to that device, or it could apply to multiple devices that are associated to that particular directory number. So our next task is to go into CIPC2, and what we're going to do is we're going to go ahead and assign a directory number for line 2 of this particular phone. All right, so we're going to go in and open up our Google Chrome. We're going to go to our call manager, 10.1.5.5, and we'll authenticate and go ahead and go through this configuration. All right, accept the self-signed certificate, proceed, and authenticate under call manager administration. So administrator, C0LL@B. All right. And what we're going to do is we're going to go into device and phone, and we're going to find the list of all of our phones that are actually registered to Unified Communications Manager. And obviously we're going to go ahead and edit CIPC-2. All right, so good device, phone, find list of phones, go into CIPC2 that's presently registered, and then we're just going to simply click on line 2 to add a new directory number. Now this template, this association template that you see on the left is what we call the phone button template. All right, there's a soft key template and then there's a phone button template. Now by default, these particular phones provide the provisioning of 2 different line appearances. We can actually modify that. Some of those buttons can be speed dials, bridge line appearances, individual directory numbers, and so on. We'll get into the discussion of templates, phone button templates, and soft key templates a little bit later on. All right. Now, before we enter any data, we're going to go down on the configuration page and see that there are actually no specific device configuration settings here. Everything that applies to this configuration is based on the line configuration settings. All right, and you can see there are quite a few settings that are available for this particular line. Specifically, we're seeing here, these are all the settings that are associated specifically with the, specifically with line 2 of this particular device. And that's why we see in this case, line 2 on device CIPC2 in this example. So all of these are device-specific configuration parameters that apply only to CIPC2. Let's go ahead and go back up to the top of the page. And at the top of the page, we're going to go ahead and put in our directory number, 11009. And then we're going to go ahead and click on another field so it actually refreshes the page. Once we click on that field, we do have the save option, which indicates that we are able to save that configuration. We can even see there that it actually says directory number configuration has refreshed due to the directory number change. Please click the save button, and then there is our directory number. That's not a circle. There's our directory number. All right. So we're going to go ahead and save that configuration. And then we'll move on to the next step. Basically, we're just adding a directory number in this particular case. All right. Now, also make note that after we save the changes, the configuration page looks a little bit different. CIPC2 is now an associated device. We're still on the directory number line appearance for CIPC2, but CIPC2 actually showed up as an associated device. All right, we're also going to go ahead and change a setting here. We're going to go down to our call forward settings, and we're going to specifically modify the call forward busy external, meaning that there's a busy trigger that gets established. That busy trigger can either be a system-wide setting or a device-level setting that allows us to identify when the phone is considered busy. And I believe that the default is after 2 calls, the phone is considered busy. All right, so we're going to go ahead and apply that setting. And then we're also going to go ahead and put in the caller ID information, which is how we can present ourselves to other individuals that we're calling. This is what's going to show up on those phones, and we'll just put in line 2. And we're going to save this configuration. All right, so we're just making some basic configuration changes right now to that line appearance. Directory number 11009 is now configured to forward all external calls to directory number 11001 when that 11009 is busy. All right. This directory number setting applies to that device. If more than one device is configured. Now, in addition, that line appearance of 11009 is configured to show up with that caller ID information. We're now going to apply the directory number that we put on CIPC2 to line 2 of CIPC3. So we'll hit go. We'll go back to our find a list of phones. We'll go into CIPC3. We're going to add a DN, and we're going to do basically the same thing in this particular case. We're going to put in 11009, click on any space there, and you'll notice that we can see the associated device is CIPC2. All right, now CIPC3 will show up after I hit the save. We can now see that it shows up on those two elements, or those two CIPC endpoints show up. Now, if I go down to the call forward busy external, we can see that that information was populated as part of this configuration because it's a shared directory number, all right? And the call forward configuration is part of that shared directory number, so it's going to apply to all the associated devices. If I look at the caller ID information, in this particular case, the caller ID information is blank because this applies to only line 2 on device number or device CIPC3. So we'll go ahead and say CIPC3, line 2, and we can save that configuration. All right, so we'll save that configuration. All right, so now if I go back to my phone, I can see that configuration has been applied on CIPC3, and it shows up on with both directory numbers. So now we're going to go to PC1. We're going to place a call to 11009. So let's go over to PC1. We're going to place a call to 11009. Keep in mind that we don't have dial tone in this particular lab, but I'll go ahead and answer that call. All right, and then we can actually go into phone number 3, and we can actually see that caller ID information. Actually, let's go to phone number 1 here. So we can see that we dialed CIPC line 2, all right? In CIPC 1, let's go ahead and drop that call. So let's go here, and we're just going to hit end call. And then we're going to place the call again, this time from CIPC 3, from that line 110, end call. Let's do that again. 11001. And we'll go back to PC1 and we'll answer that call. And now we can see that the call is coming from CIPC3 line 2. All right. And also, by the way, on the PC2, the line will show busy. It'll show that we're on a connected call with 2 parties participating in that particular call. All right, so let's go ahead and drop that call. That's just a basic configuration that shows us how we can create this shared line appearance. All right. Now, in summary, we place 2 calls basically to the same directory number, which is configured as a shared line. Both CIPC2 and CIPC3 have this line configured. When we accept the call on different phones, we get to see that different displayed caller ID because, again, that's the component that is specific to that particular device. These different numbers get displayed because we're connected to the same directory number, but we're doing it from different devices. All right, so again, there's a difference between what is going to be shared between the devices on the directory number configuration and what is going to be unique to that specific device based on the directory number configurations that we did. All right, now in task 3, we're going to configure DN-based directory URIs, and we're also going to configure user-based directory URIs. Call Manager allows us to call endpoints using a directory number or using a directory URI. And there are two ways to assign directory URIs to a phone line. We can actually configure one or multiple directory URIs at a directory number, all right? Or we can actually assign the directory URI to the directory number through an end user, all right? So first thing we're going to do is take a look at how we configure this URI at the directory number configuration page. We're actually going to go and assign a directory URI to CIPC3 by adding the URI to the directory number 11003, which is the primary extension of PC number 3. All right, I believe PC3 is where we had our call manager administration page. No, let me see if it was PC1. One of these we had a call manager administration page already active right here. All right, so we're going to go into our call routing, and we're going to go to our directory numbers in this particular case. We'll find a list of our directory numbers, and these are the 4 directory numbers that have been provisioned to this point. We're going to go ahead and click on 11003, and we're going to configure dgray at cll-collab.internal as the primary URI, and then we're going to save that configuration. So if I scroll down here, I will see directory URIs, and I can put in that primary URI information, dgray at cll-collab.internal. All right, and we can save that information. All right. Now keep in mind, as we configure a directory URI through this configuration, we just simply have to save that. That is being applied to the directory number. We also have the ability to assign a URI through an end user. All right, we can actually assign that URI, and if the end user happens to be associated to a phone, then the user and the directory number are going to be configured as the primary extension of the user. That directory URI that we're configuring at the end user level is applied to the specific primary extension for that phone. Does that make sense? So when we apply a directory URI to a directory number, that is what we just looked at, but now we're going to take a look at this from the perspective of the user configuration page. And we're going to do this on PC1, CIPC1 11001. So we're going to go to User Management, we're going to go to our End Users, and User Management, all these users are imported from Active Directory. We saw that in one of our previous discoveries. That directory URI field is a field that's synchronized with LDAP. And we can't modify it, all right? When we add a local user to Call Manager, meaning that it's a user that's not imported from LDAP, we can set that directory URI locally in the Call Manager. So for example, if I go look at JDoe, we can see that the directory URI is grayed out, or it's a non-configurable value, in other words. All right, but we see the directory URI field, and that information was populated in LDAP and synchronized. So we don't need to necessarily configure it. It would be a configurable value. For example, if I converted this user to a local user, let me tap that, convert this user to a local user, you can see that the directory URI now is a configurable field. So if this was, if we didn't do LDAP synchronization, this is still something that we could apply in this configuration. So let's go to Control Devices. And under Control Devices, we are going to do our device association. We'll find all of our devices. And in this case, we're going to select CIPC1. So we'll just say select, save and select. So PC number 1 is saved. And now if I go back, save selected changes, all right. And if I go back to User Management and I go to End Users and I find my End Users, we'll see here JDoe now has that control device listed under its control device window, all right. That directory URI or the directory number association needs to be specified as a primary extension in order for us to be able to use the URI information. So we'll see here in the user configuration, there is the ability to specify a primary number, a primary extension, and we're going to go ahead and associate that primary extension to that particular user, and we'll save that configuration. All right. Keep in mind that the directory URI is not a line appearance. We can check either the directory number or the line appearance. It doesn't really matter, but we can see that the user assigned directory URI cannot actually be deleted on the directory number configuration page. So if I go back to call routing and I go to my directory number and I look at 11,001 and I go to the directory URI information, we can see that it's grayed out here, right? I can edit the user, but I don't have an option to actually edit the URI information because it's tied to the user in this particular case. The user assigned directory has the partition directory URI applied, and we can't change the partition of that user assigned directory URI. All right, now all we need to do is go back and verify our call routing. All the directory URIs that get provisioned with a local end user or even through LDAP users are in a partition called the directory URI. We cannot actually remove this partition from the end user based directory URI, and the directory URI partition exists by default. It can't even be deleted in the system. We can rename it, but basically that doesn't do anything. It's just the name of the folder. It's not really going to change its overall functionality. To allow calls to end user based directory URIs, the search space of the calling device must include that directory URI partition. All right? We don't configure partitions and search spaces in this particular discovery, so we're not going to actually place calls to the directory URI of CIPC1, and then other than the directory URI of CIPC1, the directory URI of CIPC3 is actually not in a partition. So we can reach this URI without actually configuring calling search spaces. So we're going to verify URI call routing, and we're going to place a call to the directory URI of CIPC3 because, again, it's not placed into a particular partition. Dialing a URI from the keypad is not supported. Obviously, it would be very difficult to put in that URI information through the keypad. So we're going to use IP Communicator, and IP Communicator by default doesn't support dialing from a URI, dialing a URI from the keypad, but it does support speed dials that are implemented in a URI format. So we're going to go to the phone configuration page of CIPC2, and we're going to add a speed dial. So let's go to Device, and we're going to go to Phone. We're going to go to CIPC2, and we're going to add a new speed dial to button number 3. And here we can put in that URI information, dgray at cll-collab.internal. And we'll put in here dgray, all right, just as the label in our configuration. We'll go ahead and save that, all right, and close that window. And let's go check CIPC2. We should see on PC2 or CIPC2, we should see that, actually we're already on PC2, that dgray soft key listed there. All right, so we can actually go ahead and pull that, push that soft key, and we should see that ringing on 11,003, and sure enough, we can see the call coming in from 11,002. All right, so it's pretty straightforward configuration. The URI configuration gives us the ability to associate endpoints and directory numbers to that URI dialing. All right, and we again assign that to the directory number, or we assign it to the user. In task number 4, we're going to configure overlapping directory numbers, and we're also going to take a look at what urgent priority is. Call Manager interprets digits one by one as the digits are entered into the phone itself, right? We talked about that in our discussion. If overlapping patterns exist, especially particularly longer patterns in the call routing table, the search space that we're searching through, then the T302 timer or the interdigit timeout timer has to expire before the call is actually sent to the shorter matching pattern. Typically, you don't want users to have to wait for that timeout period, and the default time is 15 seconds, so that can be pretty significant when we're dialing. All right. They should only wait if they absolutely have to, and that's typically going to be something that we would see with international dialing rules. So we have to be aware how Call Manager performs this digit analysis, and then we can design our dial plan so that the users don't have to wait for that inter-digit timeout, and we can avoid those timeout periods. But in this case, we're going to purposely create an overlapping pattern just to see the effect. We're going to change the directory number on CIPC3 from 11009 to 110019. All right, the first 4 digits of this directory number are going to overlap with the 11001 number that exists on CIPC1, and we're adding that new 5th digit, if you will. Actually, it would be the 6th digit, really, in this case. The first 4 digits are going to match from 11009, but technically the first 5 digits would match with CIPC1. So when we dial 11001, Call Manager doesn't know if we're trying to dial 11001 or if we're adding or if we're waiting for that additional 9 to dial 110019. So Call Manager has to wait for that 5th digit or until the T302 timer expires to determine that we've actually finished dialing. All right, so let's go back to our Call Manager administration page. That was on PC1, I believe. Nope, PC2 here. So we're going to go back to our Call Manager administration page, and we're going to go to CIPC3, and we're going to change the directory number. Go there, find the phones. All right, actually, I don't know why it's going into logged in phones, but let's go to CIPC3, and we're going to modify actually the second directory number, 11009, and we're going to make this 110019. I'll click in that window and I'll click Save to save that configuration. All right. So now we're going to kind of go through the process of verifying this digit by digit analysis. On PC2 or CIPC2, we're going to go ahead and place the call. All right. We're going to do a new call, and we're going to dial 11001. 11001. Now you'll notice it's not connecting the call. It's actually not placing the call. And if I were to count, I would see that after about 15 seconds, it would eventually ring out. So let's do that. 11001, 1001. Oh wait, hold on. 1001, 1002, 1003, 1004, 5, 6, 7, 8, 9, 10, 11, 12, 13, close enough. All right, but it definitely took a long time, all right? So that interdigit timeout, that T302 timer is 15 seconds, all right? Now, we could do N-block dialing as well, ENBLOC. We can place a call from CIPC2 to 11001 using the N-block addressing method. Support for sending the call, the dialed digits, the DNIS or the called number N-block differs based on the type of endpoint, and it could also depend on the Call Manager version that you're running. It could depend on the phone firmware, if it's a soft phone, what the soft phone's software version is, or it could just be based on, well, it could be based on a lot of those different variables, right? So the documentation, Cisco documentation, would have to be referenced to see what those specific scenarios are. Different endpoints may use N-block or digit-by-digit addressing depending on how we dial the number for the endpoint, all right? But there are some options for dialing a number that may result in different addressing methods. So let's say we go off hook first. We press the new call soft key, and then we enter the digits on the keypad. Or you enter the digits first on the keypad, and then you go off hook. Or you choose a call list entry instead of entering the digits. Maybe it's missed calls or a directory. You can also use a speed dial. All right. Now in this exercise, IP Communicator does not use the N-block addressing method. It doesn't matter how you place the call. You can generate an N-block call to 11001 by calling a translation pattern that changes the number that you dialed. So for example, if we dial 11,000 and then that gets translated to 11001. Inside Call Manager, a translation pattern generates a new call setup request after it modifies the called number. And the translation pattern can be configured with the do not wait for inter-digit timeout on subsequent hops option. That's a little checkbox that you can configure. And then the translation pattern generates the new call setup request using the end block addressing method. Now we're going to configure this translation pattern so that we can generate the end block call to 11001, and then we will place that test call and take a look at the result. So let's go ahead and go into call routing, and we're going to create a translation pattern. Oops, not call park there, sorry, translation pattern. We're going to add a new translation pattern. We're going to call this 11,000. All right, and we're going to check that box that says do not wait for inter-digit timeout on subsequent hops. All right, and then we need to go ahead and put in the called party transformation mask, which is what the number is going to be translated to. Called party transformation 110019. Sorry, 1. Make sure I put the right number at the top. I think I put 11,000, yeah. And we're translating that to 11001. All right, that's a basic transformation. Take one extension and translate it to another extension. All right, so let's go into CIPC2 now, and we're going to go ahead and place the call now over to 11,001, but we're going to dial 11,000. So we're going to do new call 11000, and notice the call rings out immediately. All right. That's because of the function of the translation pattern, and also that we're doing in-block dialing, all right, which means that we didn't have to wait for that inter-digit timeout, all right. The call setup request for 11,001 is n-block, so Call Manager knows that the dialed string is complete. It actually doesn't have to wait for any additional digits, even though we do have an overlapping pattern. So that is a way of kind of getting around that. Another function that we can configure is to mark a directory number as urgent. We use a feature called urgent priority. We're going to configure the directory number on CIPC1 as urgent so that there is no post-dial delay whenever I dial 11,001, even if it's digit by digit. Now again, let's go ahead and dial 11,001, and we're still going to see that inter-digit timeout because we're not calling the translation pattern. All right, but let's go to the directory number configuration page in Call Manager. So we're going to go to Call Routing, and we're going to go to the directory number configuration page. Directory number, we're going to go to 11,001, and we're just simply going to check the box that says, let's go ahead and mark that directory number as urgent priority. So now if I go back to my phone here and I dial 11001, notice that the call gets connected immediately. All right, any pattern that's marked with urgent priority, the call is going to get connected immediately. So we can see that because the pattern is marked as urgent priority, it doesn't matter if there are any other overlapping patterns, that pattern is going to be routed immediately. This is typically not something we would do at the directory number level, but it is definitely something we would do for our service numbers, our potentially our vanity numbers, and specifically our emergency our emergency patterns, 911, 9.911, and so on. All right, so this was a basic discovery, just kind of implementing addressing on the endpoints, identifying some aspects of call routing, and we'll see you guys in the next lesson. We're going to wrap up with our summary challenge, and then we're going to get into implementing MGCP gateways. All right, so the first question in our summary challenge is, which statement best describes Dow plans? The Dow plan defines how calls are routed. That seems to sound about right? The Dow plan does certainly define how calls are routed, but is that the only thing that the Dow plan does, right? Is there more to it than just that? The second choice is dial plans define the target devices in Call Manager. That could be a component of the dial plan as well, right? If you think about it, a component of the dial plan is pointing a pattern to a destination, or assigning a directory number to a phone. But that is actually kind of a subset of what was previously defined, right? How calls are routed is actually defining the target device. So A would still kind of take precedence here. Dial plans can omit information about how to call other endpoints. I suppose that would be part of the concept of kind of eliminating patterns that are kind of too general or too generic. And that's a little bit specific, I think, in this case. Dial plans define the network topology and how sites are connected. That's definitely not the case. So in this case, the answer would be A. All right. What is the purpose of a calling privilege? For pass selection? No. Calling privileges don't define how calls get routed. Digit manipulation? Again, that's, processing the call, and manipulating the call doesn't have anything to do with actually defining if the call is allowed to proceed. Endpoint addressing, or allowing or denying calls to certain destinations. So obviously in this case, calling privileges would be, are you allowed to place the call? Are you not allowed to place the call? When dialing, which dialing method is used when all endpoints share a single PSTN number? And the communication system accepts the call by routing the call to an attendant extension, or answers the call with an IVR script, and then allows the caller to enter the internal extension. That is our two-stage dialing process. We dial one number, and then from that, either a person transfers us, or we go through some sort of dial by extension directory or something like that to be able to reach the other destination. Which component is considered a source for a call routing request? The source is not a directory URI. That would be the destination. A hunt pilot would also be a destination, and a meet me number would be a destination. So in this case, the source would be the trunk. Which component is considered a call routing target? A gateway could actually be defined as a target. Directory URI is definitely a target, so I think that in this case is going to be the answer. A call routing, a gateway could actually technically be defined as a target, but ultimately the goal, if we're sending a call to a gateway, is to ultimately send it to the PSTN. So in this particular case, the target would actually be the PSTN. Which component is considered trunk is, again, the same concept. The trunk is a way for us to get to another system, to get to the IP telephony provider. So it's not the target specifically, it's a means to get to the target. And a voicemail port is same thing, a way for us to get to the voicemail system. So even though gateway, trunk, and voicemail ports can be called destinations, they're not the ultimate target in this particular case. Which SIP routing pattern is matched when a user dials the URI bob@1.com? All right. Certainly it would match the asterisk. The asterisk is kind of the wild card that matches all SIP URI patterns, but it wouldn't match star.star.com because we only have one.com. We don't have two subdomains or two designations. Bob1, it wouldn't match at all because the domain is one. So even though A and B would match, B would be selected because it's a better match. It's a wildcard match for everything at 1.com. Which device can use SIP dial rules as an addressing method? Well, that would be a SIP phone, right? Pretty self-explanatory there. What happens if the patterns of 9.911 and 9.239xx.xxxx are configured and a user dials 9911? Cisco Call Manager must wait for the interdigit timeout before routing the call. That's not that could be potentially true. If urgent priority was checked, but the end of this particular answer makes it not true. If urgent priority is not checked, we would have to wait for the interdigit timeout T302 timer to expire in order for us to process the call. Call manager must wait for the interdigit timeout if the urgent priority option is not checked. So that would be the answer in this case. All right. Cisco call manager immediately routes the call if the urgent priority is checked, or if it's not checked, that's not true. And call manager definitely would not reject the call. The call would still be processed. It would just be a matter of waiting for that timer to expire. All right. So let's go ahead and get on to our next module.